Hello everyone, welcome to Learn Data Structures and Algorithm in Python course. In today's lecture, we'll be solving another problem on linked list. So what is the problem? It's called rotate linked list. You'll be given head of a linked list. You have to rotate the list to the right by k places. Let's say you will be given a linked list 1, 2, 3, 4, 5. Okay. Now let's say you have to rotate it by two places. Okay, by two places, k equals to 2. That means that means if you rotate for the first time, then what will happen? This 5, the last element will come first, right? Because we are rotating to the right. Okay, when you for the first time, 5 will be come at the beginning. Okay, and 5 will be our head node here. Okay, then when we rotate for the second time, what will happen? Again, whatever the last element, 4, that will come first. And 4 will become our head node, right? I hope now you have understood. And now how the linked list will be look like? It will be look like 4, 5, then 1, 2, 3. Let's take another example, 0, 1, 2, and now 0, 1, 2. Okay, now there are three nodes in the linked list, right? Now let's say I want to rotate by 4 times. That means, what does it mean? So when I rotate this for 3 times, that means the order will be as it is, right? Because the length of this linked list is 3. Now 4 means we can say this is 3 plus 1, right? So if we rotate for 3 times, then it will be as it is. Then again we have to rotate once, right? So it will be treated like rotate the linked list by 1 places. So it was initially 0, 1, 2, right? So if we rotate by once, that means 2 will become first, right? Then 2, 0, 1, right? So here you can see the output is 2, 0, 1. Let's see how we can do this. So let's say we have a linked list 1. So this is our head. Okay, this is our basically head. 1, then 2, then 3, then 4, then 5, right? And this is pointing to none, right? This is our linked list. Okay, and we have to rotate this by k equals to 2 times, right? K equals to 2 times. So let's say the k is, let's say the k is not 2, k is basically 7. So 7 mean, what does it mean? That means we have to write, so if we rotate 5 times, then it will be, the order will be as it is, right? Then again we have to rotate by two places, then we'll get the result, right? So rotate by 7 times means rotate by 2 times, that is equals to rotate by 2 times. So that we can do by using modulo operator, right? So that is easy. Okay, let's say how we can rotate by 2 times. So when we rotate by 2 times, how the linked list will be like this? So let's say we first we want to rotate by 1 times. Then what will happen? So initially it was like this, right? So what will happen? So first 5 will become, then it will be 1, then it will be 2, then 3, then followed by 4. And this is pointing to none, and this will be our head node. This is only rotating by 1 times. Then when you rotate it again, that means 4 will come to the first. So 4, so this will be our head node, then 5, then 1, then 2, then 3, right? So 3 will be pointing to none. So rotating by 2 times means that will be our expected result. Now if you observe this carefully, so what is the difference between these two linked lists? So 1 is linked to 2, next of 1 is 2, right? Then next of 2 is 3, next of 2 is 3 here also, right? So now here is the difference. So next of 3 is pointing to none. Why? Because we have to rotate this linked list by 2 times. That means these two elements will come first. That is confirmed, right? Then this 3 will be none, right? Now what will happen? So observe carefully in the beginning. So beginning, what is it look like? Here you can see 4 is also pointing to 5 here. So here also 4 is pointing to 5, right? Then 5 is pointing to 1 here. 5 is pointing to 1 here. Okay. Now let's remove this out. Let's say here in the original linked list, let's write it again or do here itself. So let's say 5 next of this 5 is none. Let's say anyhow we link this 5 dot next to 1. Let's say we link 5 dot next to 1, right? Then what we'll do, we'll break this link and make this 3 dot next to none. Now can you get the result, or then what is next? Then make the head node from here to here. This will be our head. Now can we get this result? So this is head. So head becomes 4. Now head becomes 4. So what we did, we just break this link and make this 4 to head, our head, right? And what is the next? Next is whatever the last node, that will point to our head node. That will point to our head node. Okay, 5 is pointing to 1 here. 5 is pointing to 1 here. Right here you can see 5 is pointing to 1 here. Then the remaining is done. Then we can get the result. So these are basically 3 steps. So how to do that? How to do that? So how to calculate, how to find what is k and where we can stop, right? To do that, what we're gonna do? So let me write it again. So it is 1, then it is 2, right? Then it is 3, then it is 4, then it is 5. Done, done. So this is head and this is none, right? Now let's say how we can do that. So k is equals to 2. Okay, right. Now let's say first we calculate the length of this linked list. How we can do that is basically easy, right? We can uh, take a pointer called current, then we'll go through each node, then at last, and we'll take a count variable, then we'll get a the length of the linked list. So let's say we get the length of the linked list in as, let's say, 5. Okay, because here length is 5. Now what we'll do? We have to break this node, right? We have to break this node or break this link, right? We have to break this link. Now, how we can know that where to stop? This will be our reference node. This will be our reference node. Now, how we can stop? How we can know that this is our reference node? This is simple. That is basically we have to find a difference, and difference would be nothing but n minus k. That is basically 5 minus 2 equals to 3, right? So we got a difference variable called 3, right? Then what we'll do? We'll take a pointer called, let's take, initially we have take current, so let's take currently current 2. So car 2. Okay, car 2. So let's say, let me write as c2. Okay, let's take a pointer c2 and initially point here in the head node itself. Okay, c2, and point it here. Then what we'll do? We'll change this node, change this pointer. Okay, how we can do? We'll run a while loop, and in the while loop we'll write while difference greater than 1. And then what we'll do, we'll change this pointer uh, one by one. That means we'll make this c2 to c2 dot next. That means we're traversing, right? We are traversing until when difference is greater than 1. Okay, so initially difference is 3. So what we'll do, so initially we have taken c2 as this head node, and difference is greater than 3, greater than 1. That means we'll move our pointer from here to here, c2. Okay, I got it. Okay, now what is the difference? Difference is, so 3 become 2 here, right? 3 become 2 here. Now is the difference greater than 1? Yes, right? Then we'll move our pointer again. Let's say this is c2. Now difference become 1. Now does this condition satisfy? Is 1 greater than 1? No, right? This is not satisfied. Then what we'll do, we'll stop here. We'll stop in this node here. We'll stop here. Then what we'll do, so we'll take the next node. So we have to make this node as head node, right? Ultimately we have to make this 4 as head node, right? So let's take another pointer. Let's take, so this is we have taken as head already. So let's take head 2. Okay, this is head 1, this is head 2, right? So what we gonna do? What we gonna do? To we'll take a pointer head to equals to c2 dot next, right? c2 dot next. Okay. Now head is confirmed. Okay. Now what we'll do? Now what we'll do? Now currently, if we break this link now, if we break this link now, then what will happen? Then what will happen? If we make this node to none, then what will happen? This node will be break, right? This link will be break. But currently we're not doing that. Before what we'll do? What we'll do? We have to anyhow link this last node to first node, right? We have to anyhow link this last node to first node. Then how we can do? How we can do? Again we'll do same thing. Here we have taken current 2, right? So again we'll take another pointer, let's say c3. Let's take c3. Okay. Then initially it will be pointing to head 2. Okay. Now how many times we have to traverse? How many times we have to traverse? That will be decided by this k. That will be decided by this k. So here how many times we have to traverse? That was decided by difference, right? That was difference by difference. But here it will be it will be decided by this k. So condition will be same, while sorry, not difference. Condition will be same. Here what will be the difference? While k will be greater than 1. This is the change, and otherwise it will be same. So c3 will be c3 dot next. So initially k is 2, right? K is 2, c3 is 2. So is 2 greater than 1? Yes, right? So then we will move our pointer from here to here. C3 will be pointing here. Now k become 1. Now k become 1. Now is 1 greater than 1? No, right? That means we have reached to this reference point. Okay. Then what we'll do? We'll point this c3 dot next, c3 dot next, that is currently none. We'll point this c3 dot next to head, to head, right? That was we was doing, right? That was what we are doing. So we'll do next outside of the while loop. So what we'll do? C3 dot next, that is currently equals to none, that will be pointing to head. Okay. Now this node is connected to this node successfully. Now what we'll do? There is another thing. So C2, that C2 is linked to this head 2. That we have, that link we have to break and make it none. So then what we'll do? We'll do C2 dot next equals to none. That's it. That's it. And at last we have to return this head 2. That's how we can get the result. Let's see how we can code this. So initially what we'll be doing, okay, let's say there is only one node. Okay, there is only one node. Okay, now even if you rotate it by 1,000 times, the list will look like same. The list will look like same because there is only one node, right? There is only one node. If you rotate it 1,000 times, it will be basically same. Or if the linked list is empty, if the linked list is empty, that means it pointing to none. If it is none, that will not make any sense. So that will be our edge cases. So let's write this first. So if uh, not head, that means head is none. Or let's say if head not head dot next, means there is no head dot next node, means that there is only one node. Or there is one other condition. So if k equals to 0, means we have to rotate it by 0 times. That also doesn't make any sense. Then we have to return the head as it is. So this is the first case, right? Now let's, so now what we have to do? First we have to calculate the length of the linked list, right? So let's take a variable n is 0 and let's take a pointer car equals to initially pointed to head. Then while car, what will do? Car equals to car dot next. Now we got our n. Okay, we have to increment the n also. So n plus equals to 1, right? Now we have got the length of the linked list. Now what we'll do? We'll calculate the difference. Okay, difference equals to will be, okay. So before calculating the difference, we'll modify the k. So k will be k modulo n, right? So let's say the length of the linked list is 3. Length of the linked list is 3 and k is 4. That's why will be modulo by the length of the linked list. Okay, so that we could get the actual value. Okay, now what we'll do, we'll calculate the difference, right? So difference will be n minus k, right? And we'll take another pointer. Let's say try2, initially pointing to head, then while this difference will be greater than 1, what we'll do, we'll point this card to equals to current to dot next, right? What we have written here, yeah, here, while difference greater than 1, current to equals to current to dot next. Okay, current to dot next, then we'll decrement the difference by 1. Okay, that is done. Now we got our reference node right here. C2 is come here. Then what we'll do, whatever C2 dot next, we make it as head 2, right? So we'll take another pointer. Let's say head 2 equals to current 2 dot next, right? So now we got our new head. Okay, let's take another pointer. So let's take 3 and it will be pointing to head 2. Okay, then we'll consider with k, right? So while this k greater than 1, what we'll do, we'll move this curve 3 equals to current 3 dot next, and we'll decrement the k by 1, right? Now we have reached to the last node c3, right? Then we'll make c3 dot next equals to head node. So we'll point this current 3 dot next equals to basically head, right? And what is next? Next we have this current 2. So current 2, so here we have also have to break this link and make it to null, right? So current 2 dot next equal to null, and at last we'll be returning this head 2. That's it. That's it. Let's run it. So it is accepted. Let's try to submit this. Okay, we got an error. C3 dot next equals to cut 3. Okay, I have missed one test cases, edge cases here. I think, yeah. So when I calculate this k, so if we find, so if k equals to 0, then we have to return the head. Return head. We don't have to do anything. So this is one edge cases also. So now let's say, let's run this. Yeah, it is accepted. Let's submit it. So that's why edge cases are very important while solving problem. Right now it is accepted.